Good evening, everybody. We're going to start with a question from Winter 18, Test 2, Part 1. My apologies to the morning section where I forgot my camera, so we don't have video for that, but we have video now. And here we go. We're going to go here and share our screen, I hope. I got too many windows open. Bear with me, everybody. Where's my Zoom? Oh, boy. I am looking, trust me. Zoom. Zoom. We're not seeing any of this stuff. There it is. And sharing screen right now. Whiteboard, lunches, starboard, there we are. Okay, this is a titration curve. We are titrating an acid. Do you know how I know we are titrating an acid? Just based on the curve. I'm starting with low pH and I'm adding a base. We add bases to acids. So at this point of the titration, you don't even have to remember anything about titrations. All you have to know is this was all HA, and at the end of a titration, you have no more HA. At this point of the titration, at the end, you have, oh, I don't know what I did there. This is not fun. Your share, I don't want my share screen paused. I'm not used to this computer, sorry. We're here. It says we're paused, stop share, no. Oh, what a disaster. Go back to Zoom. Are you seeing anything? Yeah, you're seeing what I'm seeing?
Yeah, it said resume when you went up there.
When I went up where?
However you got that down.
There? There?
No.
I just.
You should probably hover over the monitor, like the camera. Yeah, resume share.
Resume. It was a hovering issue. Okay. At this point of the titration, we have all HA. I was going to draw a nice line. Hopefully it lets me now. This point of the titration, we have all A minus. What's A minus represent? The deprotonated acid, also known as its conjugate base. Okay. The important thing to remember is not that you have to use this for a calculation, because we can't. But the fact that when you do a titration, this equation is always obeyed for every point on the titration. And the most important point is where pH equals pKa. Because if we can figure out where pH equals pKa, then we know the pKa of the acid, and we can pick the right acid from the list, because we know our pKa's. When does pH equal pKa? Yes, when the concentration of the acid is equal to the concentration of the base, pH equals pKa, because the log of 1 is 0. What power do you put on 10 to get the answer 1? 0. I said the same thing twice. So where is a titration halfway finished when it took 24 milliliters to fully finish it? I think I answered my own question. You're halfway finished when you've used 12 milliliters of the base. And if I drew a better line, then we'd be there. And now we're going to read the pH equals what at that point. Trying my best straight. That worked out so well. I was very lucky. So pKa equals 10, and we have the answer to our question. pKa equals pH equals 10. And I'm picking this one because that's the only acid here with a pKa of 10. And if you look at this morning's lecture notes, this has a pKa closer to 9, and you want to look at the effect called the inductive effect. It was discussed this morning. It's in the textbook. It's not a tricky little effect. But it says that if you have an electronegative atom elsewhere in the molecule, it will stabilize the conjugate base of the acid. Now, if you're stabilizing the conjugate base, that means it's easier to make it. It means the acid was stronger. 9 is stronger than 10. So yes, I could make that the right answer if I just shift my scale and have 9 up here, which I can make any of these the right answer. I'm just telling you now. I'll just adjust my y-axis. And that brings to a close that question. If you want the titration of a base using an acid, please look at this morning's review item. It's on there. And we're going to stop the share. And then we're going to hopefully stop the video and start a new segment after you